right, I am going to try and record this outside on my back porch, so it may be a little bit noisy, and if it is too noisy, then I will go in. But it's really pretty out here, so I wanted to stay outside. So we're going to talk about factors, reminding ourselves that factors are numbers we can multiply to get another number, okay? So thinking of that, it's all the different ways that numbers that we can multiply to get a number. So the reason we're going to talk about factors and how to factor a number is because I need you to understand this before we go into prime and composite numbers. So one way that I want to look at this is I have some cereal here that I stole out of the cabinet, some Cookie Crisp, and we're going to look at 6. Okay, let's look at the number 6. So I'm going to pull over 6 cookies this way. Okay. So if we're looking at the number 6, I know that this represents 6 times 1, right? An array, which y'all were really, really good at. Is there another way that I could represent this array other than the 6 times 1 and still use all of my cookies? There is. I could do 2 times 3 or 3 times 2. That's what that array would show. So because I can do an array of other than the 6 times the 1, that means 6 can be factored. So the factors of 6, so I can do 6 times 1, which equals 6. I could also do 2 times 3, which equals 6. Okay? Is there any other way that I could do it? Well, 3 times 2, but that would really give me the same thing. Okay? So those, that would give me the same numbers, the 3 and the 2. So that means that these are 3 and 2 are factors of 6. And a way that I actually write that is, I call it, Miss Webster calls it the rainbow method. I would start with all numbers can be multiplied by 1 and it gives you the other number. So I would do the rainbow here and I would go 1 times 6. And if I multiply that, it gives me 6. Okay? Or I could do 2 times 3. That gives me 6 as well. Is there anything else? Well, no, because 2 and 3 are beside each other. So these are the factors of 6. Okay? So let's take another number like, oh, my cookies just flew everywhere. Let's take another number like 8. Let me hold my paper down. Let's take 8 cookies this time. And I am going to put them 8 times 1 as an array. Okay, so that gives me 8 times 1, which we all know equals 8. Is there another way that I could represent my array to represent the number 8? Well, I could do what? I used them all. There's 8 in there, no left over. 4 times 2. So 2 times 4 or 4 times 2, it doesn't matter which way you write it. 2 times 4 equals 8. Is there any other way? Okay, so if I were to write the factor rainbow, I'm going to do 1 times 8, make the rainbow, and 2 times 4. So the factors of 8, right here, 2 and 4. Because 2 times 4 equals 8. Okay? Let's try a bigger number. Let's try 15. So I have 8, 9, 10, 11, 12, 13, 14, 15. So I know, and this one may be a really long one, across my paper. I know that I can do, all numbers can be multiplied by 1, and we've talked about that. So I know that my array, the wind, I know that my array can be The 1 times 15, if I can get them all to fit. The 1 times 15 there. Okay? It's not very straight, but I can do the 1 times 15. So I'm going to write 15 times 1 equals 15. Okay? So I'm going to put all my 15 over here. What is another way that I could represent the 15? I could do, how about 5 this way? So if I'm making my rainbow, I've got 1 times 15 and 5 times 3. So I'm going to put the 3 here and the 5 here. Are there any other numbers? And do you realize you're getting bigger? So 1, 3, 5, 15. Okay, my factors there. Okay. Let's try another number. Let's try 12. So there's 9, 10, 11, 12. Let's do 12. So I know, that was accidental. I know if I put them in one long line, that represents 12 times the 1, which equals 12. It's another way. I can make sure that I have 12 with none left over. I could do, what times what is 12? Oh, I forgot to put the 3 times 5 here. Yes, I could do 2 times 6 equals 12. Is there another way? What about, what does that represent? 4 times 3. So 3 times 4 equals 12. Doesn't matter which way I write it. So here I would have, when I do my rainbow, 1 times 12, 2 times 6. I'm going to put commas in between so I know those are different numbers. And 3 times 4. So 2 times the 6 and 3 times the 4. It makes a rainbow. So my factors of 12 are 2, 3, 4, and 6. 2 and 6, 3 and 4. Okay? All right. So really, I just wanted you to realize all the different ways. And we're going to talk about just how to factor numbers. Another way that I want, so I'm going to look at that way. I'm going to flip my paper over so we can look at one more thing for you. So that's the rainbow method. Another way that I want to talk to you about factoring is going to be called prime factorization. And we'll really talk more about prime and composite numbers tomorrow. But I want to touch a little bit on how to factor numbers, okay? So if I have, let's go back to those numbers we used a little bit ago. Let's say I have 8. If I take the number 8, I want to know and think through all of the ways that I can multiply 8. I can choose any number. So I know that 1 times 8, but that would still give me 8. I'm trying to break 8 down to the lowest it'll go before it won't go down anymore. What times what equals 8? Well, I know that 2 times 4 equals 8. Well, I can't divide anything equally by 2 other than 1 and 2. So I'm going to circle that because that becomes a prime number. And we'll talk about prime and composite tomorrow, but I just want to make sure that you understand how to factor these numbers down. Then I need to look at 4. What times what equals 4? Well, 2 times 2. And so because nothing else will go into 2 other than 1, that makes the 2's prime. So really, this number is really 2 times 2 times 2, because 2 times 2 is 4, and 4 times 2 is 8. So the prime factorization is 2 times 2 times 2. Okay? Or, if we're talking 6th grade level, 2 to the 3rd power. And we'll talk about that a little later when we get there. Okay? So let's take another number. Let's take that 12. We were just discussing 12. What times what equals 12? Well, you told me earlier that 2 times 6 equals 12. So I'm going to circle 2 because nothing will go into 2 evenly other than 1. Then I've got to come off of the 6. What times what equals 6? Well, 2 times 3. And nothing will go into 2 except for 1 in itself. And nothing will go into 3 other than 1 in itself. So my prime factorization, it equals 2 times 2 times 3. Or I count my 2's. 2's to the 2nd power, because there's 2 of them, times 3. Let's do 12 again, and I want to go a different way. What if I did, hey, I start out and I say 3 times 4 is 12. Okay? 3 is still prime because nothing will go into it other than itself and 3. And 4, well, 2 times 2 is 4. And nothing will go into 2 other than itself and 1. So it's still 2 2's and a 3. So 2 2's and a 3. So it still equals 2 times 2 times 3, or 2 to the 2nd power times 3. Okay? So either way, no matter if you start, what number you start with, when you factor a number down, you find the factors. These are the prime factors. All of these are factors of the number. So the factors of 12, we already know, are 6, 3, 4, 2. Okay? So when you find prime factors, it's all the numbers that bring it down to a prime, just the prime numbers in each number. And all numbers can be factored down to their prime numbers. But really, I just want you to focus on factorization. What numbers multiplied equal that number? So again, I'm going to flip back over here. We're going to look at today, factors are numbers we can multiply to get another number. So like 2 times 3 equals 6. Or 2 times 4 equals 8. Or 3 times 5 equals 15. So these are factored out. What about the number 7? Let's take that number. If I have 7 cookies, I can do 7 times 1 equals 7. Is there any other array that I can make out of 7 that doesn't leave it, that leaves is equal, that's a true array? Well, if I do that, I have 1 left over, so I can't do that. Let's try 4. No, can't do that. So, because there's no other array that I can make out of 7 other than the 7 times 1, that means this number, the only factors it has is itself and 1. This number is called prime. Let's take 3. 3 times 1 equals 3. Is there any other way to make an array out of that? Because there is not, other than 3 times 1 or 1 times 3. It means this number is prime. And we'll go into great detail on that on Thursday. But for now, I just want you to understand those factoring the numbers out. So the only factors that 3 have are itself, which is 3, and 1. Okay? The only factors that 7 has is itself, the 7, and 1. So that means those numbers are prime numbers. Whereas these other numbers had other ways that we could multiply to get the number. Very good.